Hi everyone, I hope you are doing quite fine. So we have learned till now to deal with the efficiencies and all, but we have not learned the method to take the efficiencies according to our needs, right? Take the efficiencies according to our needs. So we would be learning about that in the application of inverse proportional relation between efficiencies, right? So the total work that is taken and all. So let us move to the first question without wasting any time. So the first question says that if a man takes 15 days to complete a work, what part of the work will two men complete in 5 days? Now the problem here is that we do not know the whole work. How do we know the whole work, right? That is the first question we don't need. Now the whole work we do not know. Efficiency. Efficiency. Do we know about the efficiency of man? No, we do not. Now we can assume one of them because the part of work needs to be found in fraction. Whenever we would need to find something in fraction, we do not need to learn about the days, right? We do not need to uh, fear that we would get a wrong answer by taking an assumption. So we would assume the efficiencies. So assume the efficiencies as what? For making it easy to calculate, let us say that 1 unit per day is the efficiency of one person. Now it would be really easy. Now we need to find the work. Since we have seen that we would need to find the work through the whole process till now, right? 15 into 1 unit per day. Sorry for that. 15 into 1 unit per day, that is 15 units would be the total work. Okay, now we need to find the fraction. How do we know we know that we need to find the fraction? Because we need to find the part of the work that we have done. For example, if we have done 50% work, we can say that 50 upon 100 work has been done, right? That is half of the work has been done. So we would need to find that. Now the total work is 15, right? The total work is 15. How much work have we done with two men? Okay, the total work of two men would be two men are doing work. What is their efficiency? 1. And what are the number of days? 5. These are the number of work that we needed to do. So let us convert this in a general formula: number of men into the efficiency of men into number of days upon total work. Right, this is the formula that we would be using in the next few, right? In the next few questions, this is the general formula that we will use. Now let us find the answer of this question. So 10 upon 15 would be 2 upon 3 work, right? This would be 2 upon 3 work. This would be our answer. Our answer would be 2 upon 3 of the work has been done, right? It has been done. Now since we have got this method, right, product constancy, right? Okay, we would get what product constancy means, right? Okay, since we have got this formula, now product constancy is what? For example, if we are doing a certain work, so what are we doing? We have been taking the same work. Okay, we have been giving the same work to different kind of people. For example, A, B, C were doing the same work in 10, 15 and 20 days, right? They were doing the same work in 10, 15 and 20 days. Now since they have been doing the same work, we can say that they have been doing the same work. So we could have said that A into efficiency of A is equals to B into efficiency of B, right? Is equals to total work. Now whenever this condition is fulfilled, we can use a shortcut method also, or apply the general formula. What is the general formula? Number of men into days into time is equals to number of men into days into time in second scenario. This is the first scenario, this is the second scenario. In both the scenarios, as we have seen that A and B, okay, had different kinds of work. So we would need to take on the basis of the number of men. Okay, why I didn't need to use M here, I needed to use N here, right? Number of men. So the number of men. Okay, we are changing the number of men or days or time, so we would need this formula. If we needed that, okay, if there were different kind of people, let us say that this work was done by men, so we would take the number of men with the efficiency of men and date and time in the first scenario, right? That is when men work. Okay, now we could have taken the same in efficiency and D and T. This is the efficiency of all the number, efficiency, date and time are relevant to when women worked. Okay, so this is the total amount of work that we needed. Now, if the work changed, what would we do? Let us say that these people were doing 2 upon 3 of the work, right? That these people did the whole work. Okay, these people did the whole work. So what would we do? We would just divide this total, right, by W, and this total by 2 by 3W. So, okay, we can find the formula as the final formula, okay, as, let us see, N into E into D into T upon W is equals to number of women, okay, that is what I am taking here, into efficiency of women into D into T upon 2 by 3W. You can apply these formulas. Sometimes the time might not be given. Do not find time if it is not given. If the only number of days has been given, then we need to put this values. Do not include time then. Okay, some or the other values might not be given, so you would have to apply this formula. Fine, let us try to apply this formula in some easy questions. Okay, so you would better understand these things that we have talked about. We had applied this formula here, but let us apply product constancy. Okay, now 20 and 7 days. So we have seen the formula here. Number of men is 20 and we have number of days, right? So we would apply these only. Fine, okay, 20 into 7. So the number of days has been given, the number of days in the second scenario also has been given, and we need to find the number of persons. So we would just put N here and put 28 here. So we would be able to find something like this. Okay, this is crossing out as 4, and we would need to find 20 upon 4, and this would be 5 as the number of men. So we need 5 men to do the work in 28 days. Now let us move to the shortcut that we have learned. Whenever the work is constant, that means we need to do the same work in both the scenarios. So we needed to do the same work in both the scenarios. That is why we have put it as total work equal to, right? Let us put this in this diagrammatic form. Okay, we needed to find the final men. Okay, we had around 7 days earlier and we have now 28 days. So what have we done? We have multiplied this by 4. So the number of men would decrease by decrease to 1 upon 4, right? Decrease to 1 upon 4. So we would multiply this by 1 upon 4 and we would get 5 men as the answer. This is the shortcut, right? We did not need to do all this work. We just saw that it is 4 times and we just multiplied the second answer with 1 upon 4. Let us move to the next one, right? If 25 men can do a piece of work in 36 days, working 10 hours a day. So now the number of hours with days has come. So we know the formula here. Now let us apply that formula that we had learned in the 36 into 10, right? Then how many men are required? Number of men we need to find. Okay, in the second one, 20 days we have been given, 6 hours we have been given. There is no change in work, so we would not include the work, or there is the same men are doing. Okay, these men do not have different efficiencies, so we would not add the efficiencies also. Now what are we doing? You can easily find this, right? Okay, this can be crossed as 2, this can be crossed as 6, now this can be crossed as 3. So we are just cancelling them out. So 25 into 3, that is 75 men are needed. Now let us try to apply the formula, right? The shortcut method. Okay, now how will we do it? Now we have done what? Now we have two entities here. So we could have written this as 25 men and number of hours they have taken. So 360 hours in the first way. Now 25 men, we needed to find the number of men. Okay, whether it would increase or decrease, we do not know. Now 6 hours and 20 days. So 120 hours we are taking as the time. So this is the time. This is the number of men. So we have decreased the time by 3. Okay. So 1 by 3 is the value here. Now we would reverse it and we would just find 3 times value. Right, we would reverse it, we would just find the 3 times value. Now the answer would be 75 men. This is the shortcut. Right, so it is working. It is working fine. Okay, let's move to the next method, the concept of relation between efficiencies. So as I had said earlier that if we would be doing, there would be certain people in the group, right? In the group, let us say there are 6 men and 2 boys, and then 5 boys and 3 men. They are doing the same work. So how would we find the final answer? Okay, so we would need the either in the first case the efficiency. Okay, men and boys efficiency in the first case to find the answer. Let us say that they have an efficiency of 2:3. Okay, let us take that these men have 2 efficiency, right? They do 2 units of work per day. Now if we would have been given the days here, I do not know the number of days, I have not assumed them, right? I would multiply them by both the entities, right? And then I would have got the answer, right? Let us say the number of days would have been 20. Since I have not made the questions, I cannot tell you what number of days we can take. But the first method, okay, first requisite to solve this question, if one number of days has been given and the other has not been given, we need to find this, right? So we need to take it as we need the efficiency or the ratio of men is to boy efficiency. Now the second one would have been, we would have given both the number of days, right? So that we could have found the efficiency, right? In this we needed to find the number of days, in this we needed to find the efficiency. For example, we had seen the question of the package or the salary that these people were going, the efficiency is needed in that question. Now let us move to the question. 6 boys and 8 women finish a job in 6 days, and 14 boys and 10 women finish the same job in 4 days. Okay, now there are 6 boys, okay, and 8 women, okay, and they are completing the work in how many days? 6 days. Okay. Now we have been asked 1 boy and 1 woman can finish the work in how many days, right? Okay, so we have to find the total work first. This is the third type of question, total work first. We do not know it right now. Okay, we need to find the total work first. Now this has been given. Now 14 boys plus 10 women has to be given, and in 4 days they would be doing the work. Now we have this, right? We have both the days. So what do we need to find? As discussed in the last slide, efficiency needs to be found, right? Now let us find the efficiencies. So what can we do? We can take this as 36B. We can take this as 48W. We can take it as 14 into 4, that is 56B and 40W. Right? Okay. Now let us just find 20B here. I would place 20B here by subtracting this from this, and by subtracting this from this, I would get 8W. Right? So women is to boy, the efficiency of women is to boy is 20:8, that is 5:2. What would it be? 5:2. Now since we have the efficiency, how much work they are doing per day, we can find the final answer. Let us find the final answer now. Okay, now how would we find the final answer? Okay, the final answer would be, remember, we need to find one boy and one woman can finish the work. So total work we have to find now. Okay, to find that. Okay, so total work would be, that is, okay, this was also the total work. So we can put efficiencies in any one of these two formulas and get the total work. Okay, no matter where you put these values, you would find the same work. Now let us try to do it in the both ways, right? 8 into 5 plus 6 into 2 into 6. Okay, 8 5 is 40, 12 into 6. So that would be 52 into 6. I would not multiply these values. Okay, since I need, anyways, I would need to find the number of days of the work. So 52 into 6 is the total work, right? Total work. And the efficiency of one man and one woman would be 7. So 52 upon 6 into 7 would be the number of days. Okay, that is all. Okay, so I hope you can see this. 52 upon 6 upon 7 would be the number of work, right? The amount of work that we have done. And this would be the answer. You need to find this answer in the total fraction. Okay, the final fraction. This is a difficult question. These are difficult level questions which are included in the paper, and you can do it in, if you know what entities we need. If you keep on filling these entities, for example, we needed a total work, we needed the efficiency first, right? Then we found the total work of formula, we equated it, right, in the first go. This is where we have equated it, right? This is where we have equated it, right? So these are the methods that we need to apply to any question that we need to do. So we would be doing certain difficult questions in the next video, right? Okay, till then, take care and keep on practicing.